Hey everyone, welcome back to Installation 00, and this is update number 3 for Project MJOLNIR. If you're not aware, Project MJOLNIR is a GoFundMe I've set up in order to create as close to a law-accurate version of MJOLNIR Mark IV as is possible with modern technology. There is a link to the GoFundMe in the description down below, and so far we've raised nearly £10,000 to help develop this project, which is humbling and exciting all at the same time. So I thank everyone who has donated to the project so far. I thank everyone who's shared the project to their various social media feeds. And if you do want to jump aboard and help make this a reality, then please follow the link and together we'll achieve something epic. But for now, there's loads left to do, and I will leave you with this most recent update of the environment systems for MJOLNIR and kind of bringing together a lot of the things that I've developed so far, while also outlining the short-term goals for Phase 1. And there's also some very exciting news on the horizon for those of you who are holding out to see something of substance. And this is in particular reference to the helmet. So stay tuned to find out more. Cheers, everyone. Oh, shit. Getting there. Hey everyone, welcome back to Installation 00, and today I'm going to demonstrate effectively what I've got so far. This is kind of a bit more of a substantial update on actual progress and things that I've got planned in the short term. So I'm going to get right to it and walk you through what I've got, where we're going, and what's planned next. So let's do this. Okay, so first things first, the thing that's going to be in contact with your skin is the muscle sensors. I've got two different versions of the muscle sensor. I bought 36 of each for the respective muscle groups that I'm going to be working with, because I'm not completely set on which permutation of the sensors I'm going to go with now. We've got two different types. We've got this one here, which is actually the muscle sensor pickups and the myo sensor itself built into a single board, which would mount to an Arduino Nano, and they'd actually just be shielded together like this, effectively mounted to one another. That effectively would be able to pick up the muscle transductance, convert it to a digital signal, process it in the Arduino Nano, and output it as a digital signal that can then effectively just be output to a motor, to the respective servo, linear actuator, or electroactive polymer, muscles respective to whichever joint it is. So that encompasses all of it. Now they have, these are pads effectively that go onto the surface of the skin, like so. They're adhesive. They go onto the surface of the skin, and they've got really small poppers, effectively buttons on the back side there, which locate quite nicely into these. Now on this you've got three different ports, effectively three different buttons. So they clip in one here, and then the black. These two are the active sensors. So these would go laterally along the muscle from a lower point and an upper point on the muscle, and would detect the charge going across. And then the black is used effectively as your base, so that you actually have something different, a difference to measure off of. That's one permutation. The alternative permutation is the pads still go in place, but then you have these, which is exactly the same thing, but it's just a longer cable, and that goes to a muscle sensor board here. Again, it just locates in, and then this itself again would connect into the Arduino Nano. So very similar setup in both regards. The difference obviously being is that in one regard there's going to be cables, which means that there'd be conduiting effectively inside of the skin tightener suit that would lead round to the back. So I've bought 36 of this variant and 36 of this variant for all of the respective muscle groups. The trick, however, is obviously you've got skin level, and then you've got the suit, the skin tightener suit. So really simple compression layer. A compression layer, nylon spandex mix, nice and stretchy. And basically the plan is, I've instructed a seamstress basically to do quite a few jobs for me. One of them is taking these stock poppers that I've purchased on sheets basically. These will be stitched near the respective muscle group, so they're you have one on the outside and on the inside, which bridges the gap conductively through the skin tight undersuit. And then basically you have the pads on your skin, you put the skin tight undersuit over the top and click them onto the poppers, and then because it bridges the gap then to the outside, you put the muscle sensor on the outside of the suit. Then the wires, if we're doing this type, the wires that go to the servos would then be output to the respective servo, or if we're doing this type, the wires would be conduited back to a single back unit, where effectively 36 of these and 36 of these would be located in a back unit and would be centrally controlled to deal with the muscle transductors. So next step, putting it on. Bear with me. So picture, if you will, yeah, I'm wearing it. Picture, if you will, we've already got all of these pads mounted in the respective positions on all of the muscle groups. I'm now wearing this. Like I said, there's going to be conduiting sewn in by a seamstress because it's outside of my ability to do so. It's outside of my talents. And then effectively on the outside of these, you will see a popper like that on the surface. So let's say with the bicep, you'll see a couple of poppers here and then one offset here. And then the trick will be trying desperately to keep it in place. So that's going to be sewn in place to going through to the pads on the inside. Ah! It's on a runaway. We go in there like that, or probably around that way to be fair. And then on top of that would be the respective Arduino Nano all over on all of the major muscle groups. And failing that, it would be these instead. They'd be clipped in place. You'd have the blue and yellow, and then the green is the offset, and then the conduiting all the way back to the center of the back. Following me so far? Next step. Right, again, it's not pretty. This is functional. It's not been prettified yet, so to speak. Again, that's something that I'm getting the seamstress to help me out with. So all of these are actually cable ties, all these individual white marks are cable ties, and they all hold in the tubing, effectively, which also comes out of the back here. So we've got tubing there, tubing there. That's going to pump the coolant around it. So this is the tubing all held in place. These all the cable ties will be removed because it's going to be stitched in. These go up and down laterally because obviously it's zipped at the front. It wouldn't make sense to go around, otherwise I wouldn't be able to get it on. And also inside of this, you'll find these here. Sorry, black on black. Those there, they're carbon fiber heating pads. There's 5 per side of the body. There's one here, one at the side, and then 2 at the back on this side, and it's the same on the other side. And they both go down to, these will all be wired together. They both go down to on-off switches and USB cables. They take 5 volts at 1 amp. You turn them on and you feel like you're in a warm bath. It's fantastic, it really is. So this is going to be prettified, so to speak, and make it look a lot better. And there's also going to be extended tubing going down the leg. So again, on the legs of this, they'll be stitched onto the legs. That will allow cooling of the torso and the legs, and heating of the entire torso on top of. And these are going to be swapped out to a different type of glove because I'm getting some spandex gloves basically, so they closely match the material of this. As opposed to the woolly ones they came stock with, which is what these are, fingerless woolly gloves. We're going to get rid of those. We're going to use spandex gloves instead, and inside of each of them are 2 carbon fiber heating pads, simply powered by, again, it's a simple power plug leading to a USB. Again, takes 5 volts, 1 amp. They'll be in the palm and in the on the back of the hand in both. So kind of like, again, we won't be using these, but kind of like this. So you've got 1 at the front, 1 at the back here. Put it on, and again, the cabling for this would be conduited, as I said, with a seamstress who I've instructed to help me out. That'll be conduited up the back to the center back where it hits the power distribution circuit. So again, really straightforward, 5 volts, 1 amp, and your hands are nice and warm. That staves off the risk of frostbite in cold environments. Next step. Okay, so the next step, excuse me, I've been testing these out. Next step, we have effectively boots. They're very similar to wetsuit boots, effectively. The reason being is because neoprene, with the exception of the seams where the materials meet, neoprene is actually waterproof and airtight. Inside, that is a carbon fibre insole. So again, there's a carbon fibre heating element inside of that. 5 volts, 1 amp, feels like a warm bath, 40 degrees centigrade. That'll stave off frostbite in cold environments. The neoprene is also highly insulative, so it's actually very, very comfortable and warm to wear on its own anyway. Again, cables of those truncated through the conduiting up the leg to the centre back to the power distribution circuit. You still following me? Now, I suppose the whole idea behind this is so that you guys can follow what I'm doing, and if you wanted to do something similar yourself, you can. It looks like a mocap suit, doesn't it? Anyway, this next step to that. So the actual environment, quote unquote, environment suit itself. Again, I've instructed the seamstress. She's gonna effectively make this look a little bit more superhero, so to speak, because it needs to look superhero. There's going to be, I've bought a fabric which is here somewhere, but it's like a hexagonal pattern fabric. It looks really kind of futuristic, very Halo. She's going to adhere that to the surface of the neoprene on top of conduiting and various other surface features to deal with truncation of cables and tubing, and the support of the skeletal structure that would go over the top of that. And bear in mind, this is the passive skeletal structure. This is not the heavy duty one that will carry the armor plates. So, but again, neoprene, waterproof, airtight, except at the seams. She's also going to treat the seams with a liquid latex or a liquid silicone. She's not exactly sure which yet, to allow this to actually be completely waterproof and in theory airtight. And I've also asked her to put some vacuum zips so the tops and the bottoms can be zipped together, and zip to the boots, which makes a single sealed system. And gloves will also go over the top. They'll be sealed on. So basically, the only vent there will be at the neck, and that's obviously where the gasket is going to connect to the helmet anyway. So then it will be a sealed system. It will be airtight. It'll be waterproof, and it'll be comfortable above all. So neoprene bottoms, neoprene top. Bear with me while I put those on. Just before I go a step further, so I've put the bottoms on and the boots. So just before I go a step further, the actual cooling, the active cooling part of the environment suit that will be sat between the centre back will actually go through a custom port on the back of this as well. So I'll be effectively, these tubes here will be fed through an access port that will be sealed and allow the coolant to flow from the environment suit into the actual active cooling part of the environment suit. So before I go any further, so that's that one as well. I'm going to actually get rid of the logos, but I suppose it's not essential because she's going to be putting other stuff on the top of this anyway. And there will be gloves. For the sake of argument, just imagine, like, these are actually motorcycle gloves, but imagine, you know, they're actually the proper neoprene gloves that would seal to the wrist with a vacuum zip. We're getting somewhere. So on top of this would be the actual active part of the environment system. So for the sakes of dexterity, I'll keep those off just for now. This is a temporary solution. What's going to happen is onto this, I've instructed her to mount some Velcro pads over each shoulder here, as well as some webbing with some nylon straps and plastic buckles, which I have here somewhere. They're here somewhere. You have to take my word on that. They're here somewhere. Along with webbing that is just over the back there, and obviously these are just everyone knows how they work. I don't need to demo that to you. You're not idiots. You're highly intelligent individuals. So obviously this then will effectively be a strap over the back here. It would be stuck in place with the Velcro pads that will be stitched to this, and then these nylon straps here would actually be strapped across the body. So this is actually the ballistic vest that I intended on using originally, but found it was just too big to put the cooling system into. So that's why I've reappropriated it. So I'm not wasting money. Until that's done, temporarily, I've taken an old camel pack, water bladder pack that I used to use, and I've really temporarily just velcroed that onto the back of it. So that's temporary, it's not going to be like that, it's going to end up being mounted on that, but again, just for the sake of demonstration, so you know that I'm actually making headway, significant headway in the right direction. If I just adjust this, because it's a pain to get on. So again, and we've got the out tubes here. These two out tubes here, actually, I use these to simulate the circuit. These will be removed and connected to the tubes that I've actually got that are currently tucked partially down my back, but they'll come out of the aforementioned ports that I said about. So this effectively goes onto here. It's quite hot out today, and I'm still quite comfortable in this. I haven't even turned the active cooling on yet. There we go. So again, this is temporary, not going to be like this in the long run, but you get the idea. So that's going to then be mounted in the back, so to speak. And these two tubes here are the ones that actually would go into the custom port between the shoulder blades to the tubing that you know I've currently got, as you can tell by the textured surface, I've currently got going around the torso and the legs. Then it's a case of having an onboard power supply going through the power distribution circuit. That powers the pump, the Peltier pump, and all of the heating pads to be able to sufficiently cool my torso and my legs to, as I've shown with some of the screenshots, about 13 degrees centigrade, and warm me to about 40 degrees centigrade. It's actually genuinely starting to come together. The next steps after this is the passive support structure, this passive skeletal structure. Now I've got the arms available to me at the moment. I'm still adapting the legs, but again, for the sake of demonstration, I can put the arms on, at least the actual arms, and I'm working on the shoulder assemblage that will then go down the back to the torso area, to the abdominal area rather, for movement. So bear with me while I do that. So this is getting somewhere near handy now. So these on the arms at the moment are, these haven't been adapted yet. They need some WD-40. These haven't been adapted yet because these need to be adapted to be slightly longer at the wrist. They need to come up to a compound joint at the shoulder, to a central piece at the centre of the back. That would go down to a ring. These here are the beginnings of the rings. I haven't finished them yet, but these would go effectively one at the lower chest, one at the waist. These are partitioned by these here, which are actuator pistons with valves, so that would be a fluid would flow between these. So like I said, I think I've said it before, there'd be one at the front, one at the back. Effectively, when you bend at the front, it would compress this one, forcing the fluid out of this one and into the one opposite. So that would be expanded out, and that gives you the kind of floating joint that you need because of the compound joint, the compound nature of the spine. And they'd also be, so the ring of the chest here, there'd be one coming off, effectively, they're going to be at triangle, like angles to each other, like sort of something like this. So it'd come off of the chest ring and go down to a midpoint, a mid connection point, and then from there the other two would go from the bottom, that midpoint to the waist. So giving you that additional level of compound joints. So these are the beginnings of the passive skeletal structure. Again, it would be all linked together eventually. The legs are still being adapted. So they'd be on the legs. That would go to once it goes through the abdominal articulating system, it would then go into the legs. The legs would go down from the hips to the knees to the ankles, and then through into the floor, thereby transferring the weight of the skeletal system into the ground, basically, so you don't feel its weight. So yeah, we're actually getting somewhere now. And obviously there's one thing I forgot as well, earlier on with the spandex gloves that will be used there. This monitor will be effectively torn apart and will be implanted into the gloves, so that your biosigns, your blood pressure, blood oxygenation and pulse are monitored and can be sent through to the HUD systems. So I've instructed a seamstress to start helping me out with this and trying to get everything kind of, cohesive. Ooh, I think I've lost something there. I think I have, yeah. I'll look at it in a minute. To try to get all of this sort of working in unison, so to speak. The helmet is the next big thing. The armor plates and the main structure of the helmet itself, I'm actually getting 3D printed in titanium as a single unibody. that video's on the way, and it's really, really cool. Into that then will go all of the communication systems, the HUD systems, and yeah, basically everything else that's needed, and it will seal to this via a gasket, which I'm still in the process of developing, and that'll seal effectively the environment suit to the helmet, making it a sealed system. So we're actually making pretty significant headway. I haven't kind of put a video together like this where I've actually put on all the different layers so far, demonstrating the level of development and how things are going yet. Mainly out of I didn't feel that I was comfortable enough with the level of progress that had been made yet, even though quite a lot of progress has been made. I just don't. I wanted to give you something of substance. There's still a lot more to come. The helmet's the next big thing, and I'm really looking forward to showing you that. But yeah, we're actually making a lot more headway than I actually even considered myself. Once I've got it all together like this, it's actually starting to make a, you know, sort of a crazy amount of sense, so to speak. So yeah, this is where we are. I've got seamstresses, a seamstress on call effectively to you bring all this together and prettify it effectively, make it look more functional. The back unit, the pack I'm effectively wearing at the moment is a temporary solution just to demonstrate that it is all coming together, and obviously that will be put onto the webbing. The webbing will become part of the suit, so part of the torso anyway. So yeah, we're getting there. Gradually, we're getting there. The money that you've kindly donated is helping make this happen, and it's fantastic to see that so many of you guys are as passionate about doing this sort of stuff as I am. Keep sharing the GoFundMe. If you've got the money to spare, it'd be great if you could, because it helps me do this. It helps your funding helps this happen faster, and the faster I can make things happen, the more stuff like this you get. Like I said, there's still a lot of work to do where effectively the skeletal structure is bridged together and becomes a single cohesive unit, and a few other bits and pieces like the back unit here being switched out for the webbing, and then really, like I say, once the seamstress has done her work and all the EMG sensors and all that sort of stuff is in place, phase 1 is nearing completion effectively. The environment suit at the absolute base needs to be weatherproof, waterproof, and ideally airtight. And I do want to make consideration of provisions for the possibility of electromagnetic shielding, radiation shielding in the form of Demron, and a few other systems basically to put into play to help make it an even more comprehensive and cohesive system. But altogether, this is gradually coming together. After phase 1, which is what we're doing at the moment, phase 1 is the skin tightener suit, the environment system, and the skeletal structure and helmet. After we've tackled that, we're going on to phase 2. That's all of the soft armor. So it's more of the tech suit effectively. It's the soft armor. That'll probably include where I then look into radiation proofing and electromagnetic shielding and whatnot. Heat proofing to make it so it can tolerate extreme temperatures, and also looking at the actual powered aspect of the suit, so the articulators, the servos, the linear actuators, and the electroactive polymers. I'm already developing a few things in those regard anyway. And then phase 3 finally is the armor plates, the composite armor plates, the under armor plates, the heavy outer armor plates, and the power source. But it's you guys that have enabled sort of a lot of this stuff to happen so far. So still early days, still a lot left to do, but we're making headway. And thank you for supporting. I say there's some pretty cool stuff on the way, so keep your eyes peeled for that. Yeah. I can't actually turn the camera off with these gloves on. Take it easy, everyone, and find peace within the domain.